Troubleshooting noisy low-voltage lighting involves a systematic approach to identify and eliminate the source of the noise. Firstly, check the transformer location. Ensure the remote transformer is located as far from the boardroom as possible to minimize noise transfer. The further away the transformer is, the less likely the noise will be audible in the room. Secondly, inspect wiring connections. Check all wiring connections between the transformer, lights, and dimmer system for any loose or corroded connections. Tighten or replace faulty connections. Loose or corroded connections can cause buzzing or humming sounds. Thirdly, identify resonating components. Inspect the boardroom for any objects or surfaces that may resonate with the transformer's frequency, amplifying the noise. Move or dampen these objects. Common culprits include light fixtures, ceiling tiles, and furniture. Fourthly, use noise-reducing devices. Consider using noise-reducing transformers or vibration-dampening mounts to minimize transformer noise. These devices are specifically designed to reduce the mechanical noise produced by transformers. Fifthly, install soundproofing materials. Install soundproofing panels or acoustical ceiling tiles to absorb noise from the transformer. These materials can significantly reduce the amount of noise that travels through the air. Sixthly, adjust dimming system settings. Some dimming systems may introduce noise when operating at low levels. Experiment with different dimming settings to find a balance between desired brightness and minimal noise. Certain dimmer types are known to create more noise than others. Seventhly, use high-quality lighting fixtures. Low-quality lighting fixtures may produce more noise than higher-quality ones. Consider replacing the existing fixtures with quieter models. Higher quality fixtures are often better insulated and designed to minimize noise. Eighthly, consider shielding. Create a physical barrier between the lights and the seating area to block noise transfer. This could involve installing a screen or panel between the lights and the seating area. Ninthly, reduce ambient noise. Implement measures to reduce ambient noise levels in the boardroom, such as installing noise-cancelling curtains or white noise generators. Reducing the overall noise level in the room can make the transformer noise less noticeable. If the noise persists, consider consulting a qualified lighting professional who can diagnose the issue and recommend appropriate solutions. Low-voltage lighting systems typically operate at 12 volts or 24 volts, step down from the main voltage supply, which is often 120 volts or 277 volts. Transformers are used to reduce the voltage. These transformers can sometimes produce audible noise due to the vibration of their internal components. Dimming systems control the brightness of the lights by reducing the amount of power supplied to them. Some dimming systems can introduce noise into the electrical circuit, which can then be amplified by the lighting fixtures. When troubleshooting noisy low-voltage lighting, it is important to consider all potential sources of noise and to systematically eliminate them one by one. Start with the easiest and most obvious solutions first, such as tightening loose connections and moving resonating objects. If these steps do not resolve the issue, then consider more complex solutions, such as replacing the transformer or installing soundproofing materials. Here's a more in-depth look at each of the troubleshooting steps. Firstly, with transformer location, transformers, by their nature, generate some level of audible noise. This noise is typically a low-frequency hum caused by the vibration of the transformer core. The closer the transformer is to the listening area, the more noticeable this noise will be. Moving the transformer as far away as possible can significantly reduce the noise level in the boardroom. Consider relocating the transformer to a separate room or closet if possible. If relocating the transformer is not an option, then try to position it in a location where the noise is less likely to be transmitted into the boardroom. For example, avoid placing the transformer on a wall that is shared with the boardroom. Secondly, with wiring connections, loose or corroded wiring connections can create electrical arcing, which can generate buzzing or humming sounds. These sounds can be amplified by the lighting fixtures and become quite noticeable. Carefully inspect all wiring connections between the transformer, lights, and dimmer system. Look for any signs of loose wires, corrosion, or damage. Tighten any loose connections and replace any corroded or damaged wires. Use appropriate wire connectors to ensure a secure and reliable connection. Thirdly, consider resonating components. Certain objects or surfaces in the boardroom may resonate with the transformer's frequency, amplifying the noise. This is similar to how a tuning fork works. When a tuning fork is struck, it vibrates at a specific frequency. If that frequency matches the resonant frequency of another object, the object will also begin to vibrate, amplifying the sound. Common objects that may resonate with transformer noise include light fixtures, ceiling tiles, furniture, and even the walls themselves. To identify resonating components, systematically inspect the boardroom while the lights are on and listen for any areas where the noise seems to be amplified. Try touching different objects to see if the noise changes. If you find an object that is resonating, try moving it or dampening it with a soft material, such as a cloth or foam. Fourthly, noise-reducing devices can be highly effective at minimizing transformer noise. Noise-reducing transformers are designed with special features that reduce the vibration of the core. These features may include damping materials, a heavy core, or a different core design. Vibration dampening mounts are used to isolate the transformer from the surrounding structure, preventing the vibration from being transmitted into the room. These mounts are typically made of rubber or other flexible materials. Fifthly, soundproofing materials are used to absorb sound waves, reducing the amount of noise that travels through the air. Soundproofing panels are typically made of fiberglass, mineral wool, or foam. They can be installed in the walls, ceiling, or floor of the boardroom. Acoustical ceiling tiles are designed to absorb sound waves and reduce reverberation in the room. Sixthly, dimming systems can sometimes introduce noise into the electrical circuit. This noise can be caused by the dimmer's internal components or by the way the dimmer interacts with the lighting fixtures. Some dimming systems are more prone to noise than others. Experiment with different dimming settings to see if the noise changes. If the noise is only present at certain dimming levels, then try to avoid using those levels. You may also consider replacing the dimmer with a different model that is known to be quieter. Seventhly, high-quality lighting fixtures are generally better designed and constructed than low-quality fixtures. This means that they are less likely to produce noise. High-quality fixtures often have better insulation and damping materials, which help to reduce vibration and noise. Consider replacing the existing fixtures with quieter models from a reputable manufacturer. Eighthly, shielding is a physical barrier that blocks noise transfer. This barrier can be made of any material that is effective at blocking sound waves, such as wood, metal, or glass. The shield should be positioned between the light and the seating area to block the direct path of the noise. Ninthly, reducing ambient noise in the boardroom can make the transformer noise less noticeable. This can be achieved by installing noise-cancelling curtains, which absorb sound waves and reduce the amount of noise that enters the room. White noise generators produce a constant, low-level sound that masks other noises. These generators can be effective at reducing the perception of transformer noise. Finally, if you have tried all of the above steps and the noise still persists, then it is time to consult a qualified lighting professional. A lighting professional can diagnose the issue and recommend appropriate solutions. They may have access to specialized equipment that can help to identify the source of the noise. They may also be able to recommend specific products or techniques that can effectively reduce the noise level. Remember that electrical work should only be performed by qualified individuals. Always disconnect power before working on any electrical equipment. By following these troubleshooting steps, you can identify and eliminate the source of noise from your low-voltage lighting system and create a more comfortable and productive environment in your boardroom. Remember that a systematic approach is key to success. Take the time to carefully inspect all of the potential sources of noise and to try different solutions until you find one that works. Also, consider the potential for harmonics. Electronic devices, including dimmers and LED drivers, can introduce harmonic distortion into the electrical system. These harmonics can sometimes interact with the transformer and create audible noise. A power quality analyzer can be used to measure the harmonic content of the electrical system. If excessive harmonics are present, then a harmonic filter may be necessary. Also, note that the type of transformer used can also affect the noise level. There are two main types of transformers used in low-voltage lighting systems: electronic transformers and magnetic transformers. Electronic transformers are typically smaller and lighter than magnetic transformers. They also tend to be more energy efficient. However, electronic transformers can sometimes produce more noise than magnetic transformers. Magnetic transformers are generally quieter than electronic transformers. However, they are also larger, heavier, and less energy efficient. When choosing a transformer for your low-voltage lighting system, consider the trade-offs between noise level, size, weight, and energy efficiency. In some cases, it may be necessary to use a magnetic transformer in order to achieve an acceptable noise level. Another factor to consider is the load on the transformer. If the transformer is overloaded, it can produce more noise. Make sure that the transformer is properly sized for the load that it is supplying. The load should be no more than 80% of the transformer's rated capacity. Also, ensure proper ventilation for the transformer. Overheating can also cause the transformer to produce more noise. Make sure that the transformer is located in a well-ventilated area and that there is adequate space around it for air circulation. Check the transformer's temperature regularly. If the transformer is running hot, then consider adding ventilation or reducing the load. The NEC, or National Electrical Code, provides guidelines for the installation and operation of electrical equipment, including transformers. Be sure to follow all applicable NEC requirements when installing and maintaining your low-voltage lighting system. NEC Section 450 covers transformers. This section includes requirements for the location, ventilation, and protection of transformers. NEC Table 310.15b16 provides ampacity ratings for conductors. This table is used to determine the appropriate size of conductors for a given load. NEC Article 250 covers grounding and bonding. This article includes requirements for grounding and bonding electrical equipment, including transformers. Proper grounding and bonding is essential for safety and can also help to reduce noise. In addition to the NEC, there may also be local codes and regulations that apply to your low-voltage lighting system. Be sure to check with your local authorities to determine the applicable requirements. By following these guidelines, you can ensure that your low-voltage lighting system is installed and operated safely and efficiently, and that the noise level is kept to a minimum. If you are not comfortable working with electrical equipment, then it is best to consult with a qualified electrician. An electrician can safely and properly install and maintain your low-voltage lighting system.